Hello, folks, and welcome back to another episode of Long Branch Never. Today, we begin our series on 6809 assembly language programming for the TRS-80 color computer. In this first episode, we're going to be setting up our development environment. So one thing I did want to mention is that these tools that are pulled together in this tutorial here are through the work of several other individuals in the community. I picked up pieces along the way through Stevie Strow's CoCoTalk Live episodes, also through CoCo Crew Podcast, a bunch more additional information through sources on Facebook, as well as the Discord channel. And a lot of this has also come through several individuals in the community and the blogs that they've posted for the work that they've done, trying to track the work that they've been doing on games and applications, namely folks like Alan Huffman and Glew Hewlett, huge contributors to the community. So the only thing that I've really done here is I've tried to put all these pieces together into a comprehensive and fairly concise package, hoping to ease the entry to assembly coding for folks in the community. So there's several steps involved in setting up the environment, but just please be patient as we work through this. Just keep in mind that we're only going to have to go through this once, and after we're done, you'll be well on your way towards coding. So let's go ahead and take a look at the individual steps here. So the 5 key pieces that we have are the editor, and in our case, it's Notepad++ on the Windows platform. The compiler, we'll be using LWTOOLS, or in particular LW Assembler, which is William Astle's tool that he had put together. For those that may not be aware, LWASM is a cross-compiler, and what a cross-compiler actually is, it allows you to compile code on one platform, yet that code is targeted towards a different platform. Windows, in our case, for the compiling, and the target platform being the color computer. Next, we're going to be installing ToolShed. ToolShed is going to be used for doing our disk imaging. So we create our disk images with ToolShed, and we also copy our binaries to those disk images with ToolShed. Next, we'll be using emulators to test our code. We can use VCC, MAME, and XROR. Today we'll be using VCC. One of the nice things with VCC is it allows you to open binaries directly, bypassing the need for disk images. And I believe XROR does as well. I had it working at one point, and I haven't played around with it in a bit, but we'll leave that for a future episode. But even though VCC can open the binaries directly, we're going to install the disk imaging tools today because it's something that we're going to need long term, and particularly when we're going to test on actual hardware, whether we're copying those disk images to something like an SD card and using CoCo SDC, or copying them to the CoCo through DriveWire, which we may set up as a future episode as well. Also, as part of this, there's a couple other pieces we're going to be downloading and installing. There's a custom user-defined language for Notepad++, and there's also the assembly batch file that I put together from several pieces. The batch file I kind of think is the secret sauce to all this, and it really pulls everything together. And as we get into this, you'll see all the things that it actually does. So the first thing we're going to do is go ahead and download Notepad++ and get that installed. So I have links right here that I'm using, and they're also available down in the show notes in the introduction in the YouTube channel here. So I'm going to select download here. We're going to grab the 32-bit downloadable package. And we're just going to open that up directly, ask for elevated privileges. We'll go ahead and grant those. We're going to leave this default for the most part. And the only difference is we're going to create a shortcut on the desktop just so we can get to it a little bit easier. This will go through fairly quick. We're not going to open it just yet. We'll open and configure that in just a minute. I just want to get the other tools downloaded as well. So next we're going to download LWTOOLS. And this is William's page. There's a lot here. It can be kind of hard to find exactly what you're looking for. What we want to do is grab the actual binaries that have already been compiled. And Tormod Volden has already put these together, and he's been doing a pretty good job of keeping these updated. So I'll go ahead and click this link here in the middle where it says contrib/Tormod. And as you can see, there's several different versions here. What we want to do is we want to grab the latest version. That's 4.15, that's 132 zip file here. So we'll go ahead and click this and download it. I'll open that up in the download folder, and we'll extract this to the desktop. We'll move this here, and what I'm actually going to do is I'm going to rename this LWTOOLS, and the reason why I'm doing that is just for setting up the environment. It makes it a little bit easier. So next we're going to go ahead and download ToolShed. And it brings us right to the SourceForge site. We click download. Download should start automatically. Show in folder, and we'll go ahead and open that, and we'll also move this to the desktop. And just like we did for LWTOOLS, we're going to rename this just simply ToolShed. We'll take a quick peek in there, and there's a few different tools that are included with ToolShed. We're going to be using DECB, stands for Disk Extended Color Basic, and that has several tools in there that we'll be using. Disk INI for creating our disk images, and DECB Copy for copying our binaries to our disk images. Okay, so we'll go ahead and close that up. We'll go back to our steps here. Next, I'm going to grab the Notepad++ 6809 assembly user-defined language, and we'll open that up in a new tab. This is just a gist that I had put together on GitHub, and what we'll do is we'll download the zip file, and that'll be the easiest way to grab it. So download zip in this upper right-hand corner is where you want to grab that. And the assembly batch file is the same thing. We'll open that link in a new tab. And again, same thing. It's a gist that I had put together. And we can just download the zip here. You can copy and paste as well. The zip will probably be a little bit easier for the demo here of what we're trying to set up. So go to the downloads, and we've got the two here. And here's our 6809 assembly.xml. I'm just going to move this to the desktop right now. And we'll do the same thing for the assembly batch file. And where I'm going to put that, one other thing that you're going to want to do is create a couple folders on your desktop. One folder is going to be for containing our code, our source files, and I have mine named 6809 assembly code. And then the other is for the CoCo disks. I typically like to keep them separate. You may choose to put them together if you like. We'll have the ability to modify wherever you put them in our batch file when we get to that stage. So I'm going to go ahead and just put it where the assembly bat file with my code. And so I'll just do a move there. And there's that. So next we're going to want to set up Notepad++. So we'll go ahead and open that up. and just looks like a normal text editor. One of the things that's nice with it is it gives us the ability to work on separate tabs for doing our coding. Makes it nice when you're multitasking. But the big thing is being able to do languages. And it has a bunch of them built in. Unfortunately, 6809 assembly coding wasn't one of those. But the user-defined language that I had put together works fairly nice. One thing I did want to say about that, and as I'm putting this together, the custom language that I had found, or that I had put together here, was originally found on a Vectrix forum, and I downloaded it, and there was a lot of things in there for the 6809, because coincidentally the Vectrix has a 6809. So I modified it to be specifically for the color computer, and did some tweaks to it, and it came out pretty nice. And I posted on Facebook about a year ago about the environment that I had been using, and a gentleman by the name of Michael Simmons said that he had actually posted that to the Vectrix forum. So I guess he did some work on the Vectrix, and he said that he actually got the file from Steve Banford, who's been quite active in the community as well. So Steve, if you're listening, thank you for starting this file and getting this language going. And maybe at this point it's come full circle, where it's now back for the 6809 color computer. So if you are listening and you have thoughts on that, either share in the comments below, or contact me through Facebook or something. So what I'm going to do is actually open up some code that I have on here already, and this is for the game that I had put together, Star Blast. So I'll just drag and drop this into the window, and as you can see, there's a little bit of formatting already in here. What it's trying to do is the default assembly language syntax, but it's not picking up everything. Some of it's obviously picking up the comments, it's picking up the numbers, but that's about it. So what I'm going to do is I'm going to come up to language here, and I'm going to do define your language, and here I'll be able to import the file that we just downloaded. So I'll point it to the desktop. It's looking for the 6809 assembly.xml, and we'll go ahead and hit open. It says import successful, and from here we can just close this. Oops, I accidentally closed the file that I had open. What I'm going to do actually is I need to restart Notepad++ for this to take effect. So I'm going to undock that and close it. We'll close Notepad++, and I'll go ahead and open it again. And we'll drag the 6809 code back into it. Oops. There we go. Oh, that's the sem.bat. Sorry about that. We're going to want to take a look at that anyways, so I'll leave that in there. So we'll go ahead and open the assembly file, and I'll go to language, and here's the 6809 assembler. So as you can see, it's formatted, looks nice. One of the things that's a little out of place right now is it's showing us light text on a light background, and that's extremely difficult to read. I had this set up because I typically work with a dark background. So what we can do is we can come into settings, and we go to our style configurator, and from here we can pick a theme. And what I typically use, there's a couple of them, either the Monokai or Vim Dark Blue looks nice as well, and Ruby Blue. So I'll just show you what those look like real quick. There's the Monokai, so we'll hit save and close, and as you can see, that's a lot easier to read now. And we'll go back to preferences. Oops, sorry. We'll go back to style configurator, and I'll go back to the one that I actually use all the time, which is the Ruby Blue. So we'll go ahead and save and close that. So as you can see, that's a lot easier to read now. And one other thing that I like to do with the editor is if we go into preferences, and I know that I'm going to start a war with this one, But if I go to language here and over here under tab settings, tab size is 4. I replace my tabs with spaces. And I know that there's a huge debate in the coding community about tabs versus spaces. I typically like to leave them as spaces. It's a lot easier to format. It looks nicer to me long term, especially as I'm trying to compile it. So we'll go ahead and save that. And one other thing that you might want to do, depending on what your style is, I'm not a huge fan of Courier New, and that's what the default font is here. I like to enable a global font and then enable global font size, and I typically will use the console font or the concise font. And what I'll do is I'll just bump this up to 12 so it's a little bit easier for you to read. And there we go. So as you can see, it's very nicely formatted. Comments are in green. It does allow you to do some comment folding. It shows you some of the compiler directives, and don't worry about the terminology. We'll get to that later. Numbers are typically in orange here. Any of my labels or symbols are in purple, and the mnemonics, the actual 6809 assembly code is in blue. So scroll through. Another one that's nicely formatted is any of your text fields, so any of your strings. So it does a really nice job of doing the formatting. Some of the ROM calls, which we'll get into later, are also highlighted as well, some of the known ones. So that's pretty much it for setting up Notepad++. The next thing that we're going to want to set up, and I'll minimize this and minimize this, we're going to want to get our disk images created. And we're going to go ahead and open a command prompt. I have a shortcut here on my desktop. For those that want to get a shortcut to opening it up, you can hit the Windows key plus R and then type in CMD. Again, you hit Windows R and then CMD, and that'll open it up as well. So what I'm going to do is I'm going to navigate to desktop and LWTOOLS, or ToolShed, I'm sorry. And we'll do directory there. And again, there's our tools for ToolShed. And to make a disk image, what we're going to want to do is use DECB, Disk Extended Color Basic. And if I just hit enter, it'll show us what the commands are, what's available. But what we want to do is the DSK-INI, and those that remember from using the hardware, that's your format disk image, or format the disk that's in the disk drive. So the syntax here is DCB space DSK-INI, and then the name of your disk. And I'm just going to name mine assembly.dsk, and we want to put a -3 on that. The -3 option will do a 35 track disk, and that's what we're going to use as our default. You can use a -4, I believe, for 40 track, and I believe a -8 for 80 track, but don't quote me on that. I'd have to reference the documentation on it. So it looks like it created our disk image. We do a directory listing here, and sure enough, there it is, our assembly.disk image. So what I'm going to do is just going to open up the ToolShed folder, and I'm going to move the disk file that we just created into CoCo disks. And there it is. So I'm going to go ahead and minimize this here. I'm going to move back out to the desktop folder, and I'm going to change to our coding folder, which is 6809 assembly code. So we have our assemb.bat file there, and we also have our assembler code. there, which we'll be writing in the future, but for today's purpose, just to show demo, I have my Starblast source code there. So I'm going to open up Notepad++ again, and I have my asem.bat file loaded. I can turn on syntax for batch files, I believe, which isn't working right now for some reason. Oh, I know why, because I set the custom custom font, but it doesn't make a difference. So for this purpose, so the batch file, real quick, there's a few sections to it. These sections up at the top, I've set the paths which are for the tools, and I've also set the paths which are environment paths as well. The only thing that you will need to change, depending on your environment, are the tool paths or the environment paths, or both. You're not going to need to change anything else below this line here. So the way that I've got the file configured right now is exactly as I've got the folders installed on our desktop right now. You can see that we have our LWTOOLS path, which is just basically user profile / desktop.lw/LWTOOLS. The same for ToolShed. I've been using MES. You can use MES and MAME interchangeably, and we'll get to that when we configure MAME in a future episode. And then we also have our VCC path, which is /desktop/VCC, and our executable. And the same goes for XROR, which we'll be using in a future episode as well. Next, the environment paths. The diskette name is the one that we just created, assembly.disk.dsk. And our diskette path, which is just our user profile again, /desktop/CoCo disks. And then we also have the same for our coding path, desktop/6809 assembly code. And again, if you wanted to put your disks and assembly code together, you would just modify your two paths here. So that's all there is to it. If you leave everything default, this batch file should work just fine for you. One other thing that I will mention that you can change or modify at your discretion, the way ToolShed is set up is it will copy your code, your binary, to the disk image with upper and lowercase. It will not force uppercase on you. So that works fine. However, if you will be using these with physical hardware, just keep in mind that you will see the reverse text where you'll have the green on a black background, which is classic CoCo lowercase, in your directory. That might be okay for you. I prefer to keep it classic and traditional, so I set this uppercases to true, and all I did with that is I have a little routine in here, little for loop, that'll just modify anything that you put into your file name as lowercase, and it'll convert the file name to uppercase. So we'll go through the batch file real quick. I won't get into too many details. For those that are interested in learning more about it, I will definitely share with you. Just ask me in the comments below. But basically, I set up, I built some paths for doing the scripting for the assembly path, the binary path, and the disk path. I echo some of that those paths to the desktop, to the console, so you can see it as it's going. Here is the compiler doing its thing. So basically, LWASM again, choosing 6809 as the target versus 6309. I do a listing, shows symbols at the end. Output is the binary path, and then the format is this extended color basic. For those that do OS9 or other targets, then you would worry about that in a different environment. So no errors, basically, or if there's no errors, it continues. If it does encounter errors, it'll exit out. Next, it'll do the ToolShed piece, where it'll do disk extended color basic, copy, and binary file type to the binary path, it'll overwrite the file name if it's already there, and then it'll also let you know when the disk is full. And then down here is where it basically executes the emulator, and again, VCC is executing the binary directly off the disk, off of our local host OS, as opposed to pulling it from the disk image. And the way that I also have it set up, just for people that are following this, MAME is the default emulator. So if you do not have to put in MAME or MES when you put it in the command line, and I'll show you that in a second. Instead, you choose the target environment in MAME, which would be CoCo, CoCo2, CoCo2B, or CoCo3. So that is pretty much it on the batch file. And it looks like there's a lot there, and there is. I've tuned it quite a bit, but I'll show you exactly how that looks. Oh, actually, one thing that we forgot to grab, and somebody probably picked up on this, is we need to grab VCC. So I'm going to go ahead and click on the link here, and we'll get that installed. And VCC is a executable installer, and I'll have to extract all. And we do need to elevate privileges to install it. So we'll go ahead and hit next. I am going to change where this installs to, and the reason why is because if we install it to program files x86, the 32-bit install location, what's going to end up happening is, actually, I'm going to browse. It's going to be a little bit easier if we do that. I'm going to put it right to the desktop. If we installed it to program files, and I'm sure many people have firsthand experience of this, it requests elevated privileges each and every time you open it. And I know that you can turn that off, but it's definitely not advisable to do, especially if you're concerned about security. The easier thing to do is just to put it on the desktop, and it won't pester you again for that in the future. So I'm going to install it to the desktop, and I'm also going to change the name to be just VCC. So we'll go ahead and click OK, next, and we'll create a desktop icon, even though we won't be using it. All right, so it looks like we've got everything. Let me just make sure VCC is working, and there it is. So what I'm going to do now is I'm going to open up our command prompt here, and we'll do a DR listing, and we've got sm.bat, and we've got our StarBlast source file. So the way that this works is I just type in the name of the batch file. Our target is going to be the StarBlast. We leave off the .asm extension, and we just type our target. What I'm going to do is I'm going to leave off VCC for now, just to show you that it can compile and just do the output directly to the console. And there it goes. So let's just take a quick look at this. So you can see as it's going through, it's doing the assembly. Over here, it's showing us memory location, and this column here is actually the machine code, or some people call it machine language. I prefer to refer to it as machine code. It'll show us the compiled statements here, and what these statements actually compile to in the machine code. It shows us line listings here as well, and it lets us know that everything compiled okay. Oh, I went a little bit too far. And here's our symbol table at the end, showing us all our labels and symbols that were created as part of the compile. And as you can see, it's a pretty decent sized program. I think it's maybe 1,500 lines of code or so. I know that there's several other folks in the community that produce that, and they're sleep, but it's still pretty sizable. So this time what I'm going to do is I'm going to target VCC as a platform to open it up in. So I'll go through and do this again. And when it's done, it should open directly in VCC. And there we go. So we have our environment, folks. And I don't have a joystick hooked up right now, and I don't have it set up where you can play keyboard, but it'll just jump right into the game. So it's using the mouse. We'll grab some fuel. And that's it, folks. So we do have our environment set up. If you followed along, hopefully you're in the same position, and we'll just plan on getting some code written. The first episode for writing code should have out in the next few days. And I'm planning to do just a simple Hello World app. So that's it for now, and stay tuned for the next episode. We'll be writing our first assembly program. Take care. Thank you.